So part C is all about n over n squared plus 1 over, n over n squared plus 1 quantity squared. So, well, I can't apply the n-term test because the top is linear, the bottom is quadratic squared, right? So the limit is going to be 0. N-term test is not going to help at all. Well, it's not a p-series because it doesn't follow the p-series form, right? Not a geometric series, not a telescoping series, obviously. So, so the only resort you can land in is either a limit comparison test and the direct comparison test. So now the question is, what is this series related to? Like, with what kind of like series I can compare the given series? So let's just think about this. Well, this is equal to n over, let's expand this out. This is quantity squared. So this is n squared squared, so that's n to the 4th, plus twice of n squared plus 1. Okay? So if I did not have this tail, which is minor again in comparison to n to the 4th for larger n, right? Because the 4th power for a number is way bigger than the 2nd power or even a constant. So this series looks like n over n to the 4th, which is 1 over n cubed, right? So this series looks like 1 over n cubed for large n. That's good, but 1 over n cubed is a known series, right? So this is a good guess to start with because it's a known series. It's a p-series, right? For p equals to v, which is bigger than 1, and p-series are convergent whenever p is greater than 1. So I sort of like got a convergent series which behaves similar to the given series, and that's convergent. Okay, so now your task is to use one of those like tests, comparison tests, to prove that the given series is convergent. Okay, so how can I do that? Well, here we go. I have n over n to the 4th plus 2n squared plus 1, that's your an. And if I get rid of the tail here in the bottom, I can write this as like 1 over n cubed, and then since on the left you're dividing by a bigger number, obviously that quotient is going to be less than the quotient on the right, so that's my bn. Here we go. So if I add the sums here, so since this sum is convergent because it's a p-series, the sum less than a convergent sum has to be convergent, so I can go ahead and conclude that this is a convergent series. Okay? And you can pause the video at this moment, and instead of the direct comparison test, you can apply the limit comparison test. Again, you're going to compare the given series to 1 over n cubed, but this time you're going to prove that the limit of an over bn is a finite number, which is not a hard task for you because you know the L'Hopital's rule. You have infinity over infinity type indeterminate form, so this shouldn't be a hard task for you to go through. Okay. So as you see that we have learned these tests so far, and we're going to learn a few more in the following sections. But again, once there's no test specified in the question statement, so that means we have like a bunch of tests to check which one is better to apply for. Like for part C, for example, I could also apply, by the way, the integral test because I could be able to integrate this function by calling the bottom to be u. Okay, this is an integrable function, and you will see that this would probably spit out something finite so that the integral would converge, so that the series would converge as well. So again, it's up to your taste. I tried to sort of like use almost all the tests here for the given series. So this should be your set of mind when the series is provided to you without being told what test you're going to use. Okay, so you just keep in mind all 7 series at this moment, obviously, because we have more series to go in the following sections. But so far, just try out those series, whether or not you can apply them. Okay. All right, that's a long video. I'm going to finish it here. Thanks for watching. I'll see you in another video.